to measure pressure above atmospheric pressure with a manometer and a mechanical pressure gauge. B, measure pressure below atmospheric pressure with a manometer and a mechanical pressure gauge. C, calculate absolute pressure given atmospheric pressure and the measured pressure. Let's take a look at the different parts of this lab. This little part right here is called the accumulator. There's a compound pressure gauge right here. There's a compound pressure gauge. There is also something called a hand vacuum / pump. That's this device right here. All this is sitting on top of our breadboard, and the breadboard is held in place by this mechanical stand back here. You've got a support rod. It's right up in here. It goes right behind this, and it's connected with a short crossbar. It goes right through the center here, and it goes and it's connected on either side of that by two of the little rod connectors. Now this is a close-up view of the accumulator, and on either side there's some adapting connectors or caps that connect on either side, and the hoses are connected to the gauge on the other side of the accumulator. In this video, we're going to look at how pressure is the force that a gas or a liquid exerts on the walls of its container divided by the area of the container. Pressure is equal to force divided by area. Pressure is the force per area exerted on the walls of a container by a liquid or a gas. Here's something that's caused you some misunderstanding. I've already set up your lab, but I want to go over some of the parts of it. There's this long white plastic thing with the glass looking stuff on it. It's not really glass. This is the manometer. There's a little pressure gauge here, and that's 0 to 15 PSI, which stands for pounds per square inch pressure gauge. This is the accumulator, and there's a pressure pump here that's connected everything with the hose. See what it looks like on the sketch. Now this is the manometer. It's the real thing. And here's your pressure gauge and your accumulator. I'm going to start adding the liquid so that you can see it into the manometer. And one of the things that you have to do is you have to let the water column stabilize, and then you read the water levels. Now let's talk a little bit about how this thing is calibrated. Okay, so if you count the spaces from here to here, you'll see that there are 10 spaces. And the difference between 240 and 260 is 20. So you divide that by 10, and each one of these lines right here has to be equal to 2. So this first line up here would be 242, 244. 244, 246, 248, and that would be 250. 252, 254, 256, 258, and 260. Got it? The next thing you have to do is you have to look at the water column height for trial 1. And what you're going to do is you have to measure the difference between where one column of water rises on one side of the manometer and find the 0 mark and measure the distances. We'll go through this again before we do the lab. Let's look at the data table that you're going to be using in measuring pressure. And you see that you have 4 different trials, and you have a mechanical gauge pressure. And what you're going to do here is you're going to also find the manometer reading in milliliters of water, and you're going to find the water column height, which will be part of your calculations. There's a second data table that you'll use, trial 1, 2, 3, and 4, and you'll have your pressure that's measured, your atmospheric pressure, and absolute pressure. And then there are 4 questions, and we'll go over how to do these observations. Here are your questions that you'll be turning in tomorrow for your lab.